Okay, so I suppose we should just start. So what I'm going to be talking about is how we visualize data we know nothing about. And at the bottom there are two links you can find information about who I am. I've been in programming, engineering, team management for about 20 years. I've been using Go quite a lot for the last year and a half to 2 years, and we're using Go primarily in my team at the moment. This project that I'm working on it's a side project that I worked on as part of stuff I've been studying, so it isn't related to any of the work I'm doing professionally. So let's go to the next slide. So what I'm going to go through today is why would you care about visualization? Just a quick review of what's important about visualization and why it's important to us, to the world. Then I'm going to talk a bit about the state of the art of where visualization is today, and then where the gap is with where we are with all the current tooling. Then there's been a lot of research and it's ongoing, it's a current research problem, how we close various gaps with visualization. And I found an interesting paper that was written and published towards the end of 2019. And I then took that paper and I built a proof of concept. It's very, very simple proof of concept, but it demonstrates perhaps what is possible that's not currently being done in any visualization tools on the market today. And then I'm going to go into a questions session where we can delve deeper into any aspect of what I've spoken about, because in all the different parts there's endless information that you can just dig deeper and deeper into. So if there's interest and there's enough time at the end, when I finish speaking, I must keep an eye on my time, then we can dig deeper. Okay, so the first thing we're going to talk about is, or what I'm going to review with you, is why care about visualization. What's important about it, why we do it. And now really there's two, based on most of the research I read, there's two important things that we can get from visualized information. The one is knowledge gain. I think that one seems quite obvious. You can learn something you didn't know before. It's not that useful to look at some kind of image if it's telling you something you know already. It might be nice to say, hey, I know that, but it's not useful. It's not going to get you further than where you are right now. So we're looking at ways in which visualization adds value. So the one thing is knowledge gain. And the second piece is cognitive work. By cognitive work, I mean that your brain, your mind, the things you think about get engaged, get woken up. And you're looking at the image, and it's making you think. It's making you look at the data, hopefully in ways you haven't looked at it before. You see something that you wouldn't have seen, and you wouldn't have thought more about. It may not immediately give you any new knowledge, but it will lead you to thinking about things in a new way, which could lead to innovative behavior and new kinds of knowledge. One of the well-known thinkers around visualization is I don't know how his name is necessarily pronounced, but it's Van Wyk. And he speaks about how the human mind and the eyes work together, and that you can see something very, very quickly with your eyes when you look at an image that you would never see just looking at data or just looking at the written word, which you can probably see from this, because this is just words on the screen there. It's not a visualization of anything. The second point, I think, which I tried to emphasize earlier, is that the value of visualization isn't in learning something you know already. It's about building new ways of thinking and finding solutions or ideas or problems that you didn't even know about before. And then in terms of where we are today in the modern world, if we can automate ways of visualizing data in ways so it shows us something we haven't thought about before, then that's just a good for the individual, it's a good for the world, it's a good for society. So that's what Van Wyk had to say. And a second thinker, Colin Ware, stresses that the faster we can do this and the better that we can do this, it adds value. And then he cynically pointed out that most of this value has monetary value as well. So that's definite incentive for virtually everybody. So the problem that we have with getting visualization from data is, I think, quite neatly summed up in this mathematical equation that Colin Ware put in his book, which is one of the seminal works if you do want to learn about how the mind works when looking at images. And he points out that in order to use a visualization, this is the cost. The first part is how long it takes to learn how to use that visualization multiplied by the value of that specific user's time. Because time is probably the most expensive thing. And then that gets added to the time spent actually building that visualization multiplied by the value of that user's time. Now, there are a lot of skills involved at this point. There's the skill of the subject matter expert that actually knows that data in question. But it's more than that. It's also the skill of the people that are going to be building that visualization. It's understanding the database that the data is stored in. It's knowing what tables are. It's probably knowing what SQL is. I assume everybody here knows what SQL is. Maybe let's ask. So maybe with a show of hands, how many people here use SQL regularly? So that's not even every hand, although maybe some people just didn't raise their hands, but we're experts. And it took us time to learn that. And to use SQL well, that's not an easy thing. As people here who use SQL a lot probably know using it well is different from just using it. In terms of performance, in terms of maintainability, there's a significant amount of skill there. And SQL itself isn't enough for the visualization. It's just one of the skills you need. There are a lot more skills. So here I've got the first visualization in my slideshow, and this is a very famous one. It's from maybe one of the first works about visualization by a man named Edward Tufte. And what he has here are pictures of the United States of cancer incidents between 1950 and 1969 for females on the top and for males at the bottom. And then immediately, just with your eyes, you've probably picked up information already that's telling you stuff you didn't know before and making you think about stuff. For example, you can see in the top northeast, there's definitely something happening there because there's more cancer there. But you also notice, if you then start looking across it, you start noticing differences that start raising questions. For example, you can see that for males in certain areas, there's a higher prevalence of cancer than for females. So something is going on there that's not related to geography and related to what the men are doing and what the women aren't doing. And I think, but I can't remember definitively, that it was related to the mining and the mines that the men were working on in that part of the world where there was exposure to cancer-inducing agents. So immediately from this information, people can start doing things to make people's lives better that wouldn't have been obvious from before. Also, you start seeing hotspots which can start be triggering national-wide action. Similarly, with other kinds of things, a visualization like this is very, very helpful. So I hope I've managed to get across the importance and the value of visualization. So I'm now going to spend a minute or so on where we are with the current state of the art. Now, perhaps the two of the top visualization tools today are D3 and Tableau. On the top left on the slide, you can see some of the images you can produce with D3. I don't know, maybe a show of hands, how many people here have worked with D3? So a few people, less than half, I think. And D3 isn't trivial to use. You have to know a significant amount about how JavaScript works, but even that's not enough because D3 itself is a domain-specific language written within JavaScript. I think it's what's called a embedded domain-specific language, which means you're actually learning a second language within the first language in order to use it. And then once you've learned that language, being able to build professional images from it is a third stage. So that's a significant skill. Using D3 well, you don't get easily, and you don't achieve easily either. It takes months. I mean, you can get something that looks nice. You can go to open source libraries and you can copy and paste something someone's done before to get something quickly out the door. But to use it efficiently, effectively, and smartly is a skill. On the bottom left, I've got a bit of an image from Tableau. You can see there they've got a tool interface where someone who understands already the tables underlying the data needs to pull things, drag things, drop things, look at images. Now, if that person doesn't know the data as a subject matter expert, they're just looking probably for pretty pictures, or they're trying to find something that people already know in order to just give them back the information that they know already because of, I think, what's bias? That cognitive bias. People like seeing stuff they know already. So if you give people stuff they know already, then they're very happy with you. It's not value adding. And so I hope I've made clear that although the state of the art today is very beautiful, we can do things today that we couldn't do 20 years ago. There's a significant skill gap in between taking data and turning it into beautiful pictures that actually provide value. So I think that there's no way I can emphasize enough the amount of skill it takes to be able to do a good job of actually finding visual information within data and presenting it to people to show them stuff they didn't know before. So this is recent research that has come out of Imperial College and Birkbeck University, which are both London universities. Two professors there have been working together in researching how we can close that gap and try and automate useful visual information from databases, taking out the necessary skill that currently it requires. I've got a little picture there just to tell you that I'm going to delve deeper into this. You don't need to understand everything on the screen right now, but I do encourage you, I'm going to make these slides available, to come back later and to read through what's written on these slides and to think about it if this is the kind of thing that interests you. But essentially, the key piece of information in this slide is that there's certain patterns within data that can be seen to be represented within different kinds of visual representations that make sense for that kind of data. So if you can find those patterns in the data, you can automatically generate a visualization of that piece of information. What they do stress is that these are affordances, these are guides. It's for someone that understands the data to be able to look at it and go, this is interesting, and go deeper. And these other pieces of information that are visualized isn't that interesting. A simple example, I think, which is quite famous, is there's correlated data in Australia showing that the rise in shark attacks happens at the same time in which people buy more ice cream. And that would come up as something that is interesting for visualization, so you would get a graph for that. But an expert would be able to pick up that that's not that interesting and not go further with that. So again, this is from the slide. I'm going to dive deeper into this slide with one or two actual worked examples that hopefully will start ringing bells and start making sense. The On the left-hand side, I have what are described by the research as visual schema patterns, visualization patterns. If you can find a pattern that looks like something called a basic entity, then you can then represent that as a bar chart, a calendar chart, a scatter diagram, a bubble chart, a chloropleth, or a word cloud, for example, depending on information, metadata that's stored about that basic entity. So what is a basic entity? Again, I will dig a bit deeper into the next example, because I'm going to actually show worked examples of the basic entity and the weak entity. But before I do that, let me just revise it. So a basic entity you can think of as a table. A table is an entity. On the left-hand side, you've got attributes. So if you know databases and you know tables, each attribute is a column. And then on the right-hand side, you've got a K. K stands for key. So you've got key, attribute, and entity. So you have a key, perhaps country name, which is the exact example I'm going to show you. And you've got some attributes, perhaps population. And then immediately you could get a bar chart on the bottom, all the country names, and then different heights of bars for the population numbers for that country, for example. A weak entity is when you've got a compound key in which, for example, you've got a city in a country. So then you could then start seeing comparisons of, for example, population, which is the example I will work, showing how populations within cities have changed per country or per some other kind of example. And then, as you can see, that there are two entities. There's one compound key made up of K1 and K2, and the number of attributes down the left. I'm not going to dig too deeply into the other examples, because maybe I'm hoping that based on my explanation of the first two, you can understand that a one-to-many relationship, a many-to-many relationship, and what a reflexive relationship is. Each one of those could be represented by the different kinds of visualizations described on the right. I have referenced the paper at the bottom right, if people are interested in digging deeper. So I'm going to now work an example. How much time do I have left, just so I can time myself? 10 minutes. So what I'm going to take to work this example is something called the Mondial database. Now, probably none of you have heard of the Mondial database. A lot of us have heard of the Northwind database if you've been in programming for 20 years, because Northwind was the one that came as the example database with Access 97. Anyone here used Access 97? Maybe a show of hands? Yeah, so I spent years of my life with Access 97. I don't recommend it. You have to repair it on a frequent basis. There wasn't a button called Repair Database when it stopped working. And this is the schema of that database. Not that database. And then Oracle has one. I know they've got a customer database that people do a lot of examples with when learning how to use databases. So in academic circles, there's a database called the Mondial database that was produced by a German university from web scraping. In the appendix in my slides, there's an actual list of the source of the data. But essentially, it provides information about countries, the population of that country, the economy of that country, what continent it is in, geographical information about religion, about languages, about various different things. And I have produced a Postgres database that has all this information in it, that's running, I'll describe in a few seconds, the actual architecture, which is a microservice architecture running in Kubernetes. And on the left, this is me going execing into the Docker container, running in the Kubernetes environment, and listing all the tables. So what I'm trying to just make clear here, before I run the examples, is what the data is that we're going to be generating information from. So the assumption is, with this information, we should be able to automatically get visualizations that are interesting and that teach us something we didn't know before. Again, I'm going to go into the architecture in a minute or two's time, but it's a microservices architecture. Ignore Ghost and ignore Zulip. That's something I'm experimenting with at the moment. But there are 1, 2, 3, it's 6 microservices all running together, which produce the prototype that demonstrates and actually works the research, which I'll actually demo for you live, so you'll see how it works. So before, did the sound go? Okay, it's still good. Okay, so I'm going to do a quick live demo now because I've been talking a lot, and I don't know how much of you, how dry it's been. So I'm hoping to maybe give you an example of what it actually looks like. Now, first of all, although I've been working in computing for 20 years, I work very hard to avoid the front end. I profess I don't know what's going on. I look confused. I start working on something else. I'm not a front end expert. So excuse the fact that it's not so pretty. Just try and understand what I've done underneath it. So this is a live running example of implementing that research. So what I've done is I've got the database and I've matched patterns against it, and it's automatically generating all the visualizations down the left-hand side. Obviously, you can do clever things with drop-downs. I don't know how to use a drop-down, so I haven't done that. So for example, if I want to see, and again, it's not so clear what's going on there because the writing's really small, but this is a bar chart that's generated automatically using the visualization patterns from using the basic entity visualization pattern that I showed earlier and for country and population. So for example, that one that's really tall, that's China, and that's India, and then over here is the USA. So I don't know if people have always heard that China's got more people than the rest of the world, but it really, when I looked at this, I never realized how significant that was. Another interesting thing that I learned straight away when I looked at infant mortality is that something's really going on in Afghanistan. A lot of children are dying in Afghanistan, and we should find out why. It seems to really be high. Another example are scatter charts or bubble charts. So here are some bubble charts. So here we can see, I think, employment versus agriculture is probably not that interesting. GDP versus unemployment. And then if you're studying the economy, this kind of thing might make sense to you. I don't know anything about the economy, so I don't know necessarily. But it shows you on a logarithmic scale as the GDP increases, what happens with unemployment. I think we can obviously see a curve going on there. You can see wealthier countries have less unemployment, and countries in which nobody's working isn't making that much money. So some of it's quite obvious. That's an obvious one, which is the one I showed you here. Some of the more pretty ones well, okay, let me show you this one, because this is the other worked example I'm going to show you in a few seconds. But this is population of cities. So you can see Shanghai is now the biggest city in the world, according to the data from this database. But interestingly, it wasn't then. There's been, over the last 20 years, Shanghai's population has gone up from when in the 1980s or 1990s, it wasn't the biggest in the world. And then another example is Istanbul. So Turkey's population has increased significantly. This stuff's interesting. When I play with this and I look at it, I'm learning stuff I didn't know before. So I believe it does work. And then at the bottom here, I've got one that I think is the prettiest, so I'll quickly show you some of them. So this is the chord graph that gets generated from many-to-many relationships. And this is borders between countries. So for example, if you look here with China, you can see all of its borders. Or if you go look at Syria over here, where people are fleeing, you can see where they flee to, which is to Israel. Well, they can't get through to Israel. To Iraq, to I don't know all the letters there, but those are the countries they go to. Okay, so I hope that's maybe shown you what can be done. I know it's not pretty, but that's just D3, and I saw there's some people here that work with D3 a lot. You can do something very, very beautiful with D3 with this data very easily. So let me jump back to other way to the demo. So also, if you want to dig deeper into this, all the code is I've licensed it under the MIT license. So you can just go take it, you can contribute to it. I'm using Travis to deploy it, and all the containers are on Docker Hub. So this is the basic example. Again, I'm just showing the data it's coming from. So this is taking the data from the country table. So this is some of the country information. And this is the pattern it's matching against. So some of the metadata around that table. And this then I've exposed through a microservice that exposes it as CSV. So any data can be exposed as CSV. I've called it the simple microservice, simple query, because D3 works really well with CSV. So this way D3 can just plug into it. And here's the example I mentioned before with China, India, and America with the population. The second example, again, I showed it a bit earlier, is the weak entity relationship. That's with the line charts when you've got compound keys. And you could produce other kinds of visualizations with this. I'm starting to move a bit faster because I think I'm running out of time. So the way this was built with microservices. I ran this on the cloud. I had to choose a cloud provider, so I tried AWS, I tried Azure, I tried Google Cloud, and in the end I used DigitalOcean because it's the cheapest, and I was paying for it. The others offer much more services, but they cost more, so it depends on what you want. I didn't need 3 availability regions. So Kubernetes I chose as the microservice orchestrator. I think it's won the game. Is anyone here using a microservice orchestrator that's not Kubernetes? 2 people. So you're behind the game. Oh, no. Good luck. All the mind share is somewhere else. So I'd be careful there. What I did was I built, as I said, 6 microservices. I built the user interface you saw there. That's running as a microservice itself. The D3 images are running as a separate microservice. The list on the left-hand side that gives you the list of all the possible matches, that's a 3rd microservice. There's a 4th microservice that turns the database table you saw into the CSV. And then this is one microservice. I put it in a square. And what it's done is it's taken all the data out of the entity relationship Postgres database and stored it in a semantic database as RDF triples. And that's what the query is running against, using something called Sparkle. Again, I'm not going to spend too much time now because we're running out of time. But at the bottom here, I have links. So you can use the slides. You can, for example, go and see this runs the one microservice by itself. This one runs if I can try to click it, maybe the one at the bottom. This runs the matcher. So these are matches coming back via Sparkle query. This is a way of running the Sparkle query directly against the microservice running the graph database. So you can run this. It's just an example. But that query there is actually inside the service that does the matching for you. And then D3 itself, I'll go back out of space. D3 itself is a separate microservice that produces the image based on what you selected as the match. This is how the actual process happens in which you extract the data out of the database, turn it into a graph database so that you can do the matching. How much time do I have left? A minute, so I'm not going to delve deeply into this. If you want to, I'm free for questions. You can come ask me. As I said, all information is available, and I am the only person with my name that exists in the world, so it's very easy to find me. I don't need to be on any fancy social media. You Google my name, you find me. End of story. I'm not going to do any more with the live demo. This is a sequence diagram. It actually shows how the whole process works and how you get from the dashboard. When you click on the dashboard, it runs a match, comes back with the possible matches, presents it on the left. You then choose a graph. It then goes and it gets the CSV data from the database. It provides it to the D3 microservice, which in returns the image and puts it on the screen. So I think I've got maybe 30 seconds for questions. I'm not sure. Any questions?
I think maybe if you have to take questions during the break or at the social.
I'm free to take questions whenever anybody ever asks me questions, anytime from now till the end of time. So it doesn't just have to be then. Thank you.